So you're telling me that in 2003, researchers tagged a 9-foot great white shark, one of the ocean's most terrifying predators, and 4 months later, something ate it?
Not just ate it, dragged it nearly 2,000 feet into the abyss, swallowed it whole, and carried the tracking tag around in its stomach for 8 days before, well, nature took its course.
I'm sorry, 8 days? Whatever ate a 9-foot great white shark took over a week to digest the evidence?
The tag, at least. The shark itself was probably processed much faster. But yes, 8 days of data showing this thing cruising between the surface and about 300 feet of depth, breathing air, maintaining an internal temperature of 78 degrees Fahrenheit.
Wait, breathing air? So we're not talking about another shark?
That's exactly the question that's haunted marine biologists for over 2 decades. Welcome to the 9-foot great white that vanished. What hunts the hunter? I'm Dr. Elena Vasquez.
And I'm Marcus Chen. Today we're diving into one of the ocean's most chilling mysteries, a case that challenges everything we thought we knew about who's really at the top of the marine food chain.
Fair warning, by the end of this episode, you'll never look at great white sharks the same way again, not because they're more dangerous than you thought, but because they're more vulnerable.
The hunter becomes the hunted. Let's get into it.
All right, Elena, set the scene for me. November 2003. What was happening?
Australia's first large-scale great white shark satellite tagging project was underway off the coast of Bremer Bay in southwestern Australia. A team of researchers, along with filmmakers Dave and Janine Riggs, were attaching tracking tags to great whites to study their migration patterns along the coast.
Standard research stuff.
Exactly. The tags were designed to record ambient water temperature and depth, then periodically transmit data to satellites. The first shark they successfully tagged was a healthy 9-foot female they nicknamed Shark Alpha.
9 feet. How big is that in shark terms?
Here's where it gets interesting. 9 feet sounds massive to us. That's longer than most cars. But for a great white, she was actually on the smaller side. Female great whites typically reach 15 to 16 feet at maturity, and some grow over 20 feet. Shark Alpha was likely a young adult, maybe a teenager in shark years.
So she wasn't some tiny baby shark.
Not at all. She was a legitimate apex predator weighing close to a ton, packed with muscle, capable of taking down seals and sea lions. By any reasonable measure, she was near the top of the food chain.
And the tagging went smoothly.
Perfectly. The tag was securely attached, Shark Alpha was observed swimming away healthy and strong, and the team started collecting data. For 4 months, everything looked normal. Typical shark behavior, standard diving patterns, nothing unusual.
Until Christmas Eve.
Until approximately 4 a.m. on Christmas Eve 2003. That's when the data gets disturbing.
Walk me through it.
So, Shark Alpha had been swimming along normally, near the continental shelf. Then, abruptly, she changed course. The tag recorded her plunging rapidly, and I mean rapidly, to a depth of 580 meters, which is about 1,900 feet.
How deep do great whites normally go?
They typically stay in the upper 900 feet or so. They can dive deeper. Some have been recorded at over 4,000 feet, but it's unusual. And this wasn't a leisurely descent. This was a plunge.
Like she was being dragged down?
Or fleeing something. But here's the critical data point. Seconds after reaching that depth, the tag's temperature reading jumped from 46 degrees Fahrenheit, the ambient water temperature at that depth, to 78 degrees Fahrenheit.
A 32-degree spike.
In seconds. And that temperature, that's not ocean water. That's the inside of a digestive system.
So, the tag was swallowed.
Along with Shark Alpha, presumably. The tag continued recording for 8 more days, showing movement patterns between the surface and about 300 feet, which is consistent with an air-breathing animal.
Then the tag was eventually expelled, and it washed up on a beach about 2.5 miles from where Shark Alpha was originally tagged.
Okay, I have about 17 questions. First, how do we know the whole shark was eaten and not just, I don't know, the tag got bitten off?
That's been debated. The tag was designed to attach securely to the dorsal fin. For it to end up in something's stomach, that something would have to either bite through the dorsal fin area, which would likely kill the shark anyway, or consume enough of the shark to ingest the tag.
And the temperature data rules out the tag just falling off and sinking?
Completely. Ocean water at 580 meters is cold, around 46 degrees. The tag recorded 78 degrees for 8 consecutive days while moving in patterns consistent with a living predator. That temperature can only be explained by being inside a warm-bodied animal.
So something with a body temperature of 78 degrees ate this shark. What has that body temperature?
And that's the million-dollar question. Great white sharks are actually warm-bodied to some degree. They can maintain muscle temperatures about 25 degrees above ambient water. But 78 degrees is too warm for most sharks. It's more consistent with marine mammals.
Like an orca?
Like an orca. But here's the problem. Orcas typically have body temperatures around 97 to 100 degrees Fahrenheit, similar to humans. 78 degrees is actually cooler than you'd expect for a mammal's core.
Unless
the stomach temperature was being cooled by ingesting cold seawater along with the shark, or by the cold mass of the prey itself. When you swallow something that's been swimming in 46 degrees water, it's going to bring your stomach temperature down temporarily.
Okay, that makes sense. But what about the depth? You said the attack happened at 1,900 feet. Do orcas dive that deep?
They can, but it's rare. Orcas are typically found in the upper few hundred feet. However, and this is crucial, when you look at the data more carefully, there's a strong argument that the attack didn't happen at depth. The shark may have dove deep trying to escape, and the predator caught up with her at the bottom of her dive.
She was fleeing.
There's documented evidence that great white sharks will dive deep when fleeing from orcas. It's a known behavior, trying to outlast an air-breathing predator by going where it can't follow. But if the orca was fast enough, determined enough,
It caught her anyway.
and dragged her and the tag back towards the surface. Remember, after the temperature spike, the tag showed movement between the surface and 300 feet for 8 days. That's consistent with an air-breathing animal digesting its meal.
So, the leading theory is an orca.
One of the leading theories, but there's another possibility that the documentary and many researchers have focused on, a much larger great white shark.
Shark cannibalism.
Exactly. And before you dismiss it, there's substantial evidence that great whites do eat other sharks, including other great whites.
Okay, so we have two main suspects, a killer whale or a cannibal great white. Let's examine the evidence for each.
The case for the orca, the behavior patterns after ingestion match an air-breathing animal. The temperature is within the range you might expect for a mammal's stomach that's been cooled by cold prey. And orcas are documented predators of great white sharks.
And the case for a larger great white?
Great whites can maintain elevated body temperatures through a specialized system called the rete mirabile, a network of blood vessels that retains heat. A very large great white could potentially maintain a core temperature around 78 degrees, especially after consuming a large cold meal.
how big would this hypothetical cannibal shark need to be?
Based on the thermal data and the fact that it apparently consumed a 9-foot shark, researchers estimated at least 16 feet, possibly weighing over 2 tons. Some have speculated even larger, up to 20 feet.
And sharks that size exist.
Absolutely. The largest confirmed great white was about 20 feet long, and there are credible reports of sharks exceeding that. A shark named Deep Blue, frequently spotted off Mexico and Hawaii, is estimated at 20 feet and over 5,000 pounds.
So both theories are plausible.
Both are plausible, but here's what makes the orca theory compelling. Since 2003, we've accumulated overwhelming evidence that orcas don't just occasionally kill great whites, they actively hunt them with terrifying precision.
You're talking about Port and Starboard.
I'm talking about Port and Starboard. And they've changed everything we thought we knew about ocean apex predators.
All right, Elena. Port and Starboard. I've heard these names thrown around in shark circles like they're supervillains. Who are they?
They're a pair of adult male orcas who've been terrorizing great white sharks off the coast of South Africa since at least 2015. They're named after the nautical terms. Port's dorsal fin collapses to the left, starboard's collapses to the right.
Collapsed dorsal fins, like you see in captive orcas?
Similar appearance, though the cause in wild orcas isn't fully understood. Some researchers speculate Port and Starboard may be older males, or there could be other factors. But regardless of why their fins look that way, these two have developed a hunting technique that's unprecedented in its precision.
Explain the technique.
They target great white sharks specifically for their livers. They'll attack the shark, flip it to induce a paralyzed state, then make what researchers have described as a surgical incision between the pectoral fins to extract the liver, and only the liver. The rest of the shark washes up on shore, mostly intact, with just this precise wound.
That's incredibly specific. Why the liver?
Because a great white's liver is essentially a massive energy reservoir. It can make up to 25 to 28% of the shark's total body weight. In a large shark, that's hundreds of pounds of organ. And it's filled with an oil called squalane, which has an energy density higher than whale blubber.
So the liver is like a giant battery pack.
Exactly. Unlike bony fish that have swim bladders for buoyancy, sharks rely on their oil-filled livers to stay neutrally buoyant. The squalane is lighter than water, so it helps them float without constantly swimming. But for an orca, that liver is basically the most calorie-dense meal in the ocean.
One researcher called it like comparing coffee to energy drinks.
That's a great analogy. Whale blubber is coffee, good energy source. Shark liver is multiple cans of Red Bull. And Port and Starboard have figured out that they can get this massive caloric payoff without having to process the entire shark.
How many sharks have they killed?
Since 2015, at least dozens of confirmed kills. In August 2019 alone, 5 great white carcasses washed up with their livers surgically removed. In February 2023, they killed at least 17 7-gill sharks on the same day off the coast of Pearly Beach.
17 in one day?
All with their livers precisely removed. Same technique, same precision. These aren't random attacks. This is systematic hunting.
You mentioned they flipped the sharks. How does that work?
This is where it gets fascinating. Sharks have a reflex called tonic immobility. When you flip a shark upside down, it enters a paralyzed, trance-like state. Its muscles go slack, its breathing slows, and it becomes essentially helpless.
Like a biological off switch.
Exactly. Researchers use this technique to handle sharks safely during studies. But orcas, incredibly intelligent animals that they are, have figured out how to exploit it as a hunting strategy.
They learned to hack the shark's nervous system.
Marine biologist Ingrid Visser has documented orcas ramming into sharks at high speed to flip them upside down, inducing tonic immobility. Once the shark is paralyzed, the orca can take hold of the pectoral fins and extract what it wants.
And the shark just lets it happen?
The shark can't do anything. It's physiologically incapable of responding. The paralysis typically lasts about 15 minutes, which is more than enough time for an orca to do whatever it wants.
That's horrifying from the shark's perspective.
Nature's metal, Marcus. But here's what makes Port and Starboard truly remarkable. They've gotten so good at this that one of them can now do it alone.
Wait, what?
In June 2023, researchers witnessed Starboard kill a 2.5 meter, that's about 8 feet,
juvenile great white shark entirely by himself. The whole process took less than 2 minutes.
2 minutes from attack to liver extraction.
2 minutes. He was later photographed swimming past the research vessel with the shark's liver in his mouth. One researcher described it as very Silence of the Lambs.
Okay, I need to sit with that image for a second. An orca swimming past a boat casually carrying a shark's liver like a trophy?
And this is the first time we've ever documented a single orca taking down a great white alone. Previously, all observed attacks involved multiple orcas working together over periods of up to 2 hours. Starboard has refined the technique to the point where he can do it solo in under 2 minutes.
That's not just hunting, that's mastery.
It's exactly mastery. And it suggests this behavior is learned and perfected over time, not purely instinctual. Orcas are known for cultural transmission of hunting techniques. Different pods develop different specializations that get passed down through generations.
So Port Starboard didn't just discover this technique, they've been practicing and perfecting it.
For at least a decade that we know of. And the consequences for great white populations have been dramatic.
How dramatic?
False Bay near Cape Town used to be one of the best places in the world to see great white sharks. Researchers documented over 300 sightings across 8 beaches in 2011. Since Port Starboard started hunting there regularly, great white sightings have dropped to essentially zero.
Zero?
Zero. No confirmed great white sightings in False Bay since 2019. The sharks have completely abandoned the area.
They fled.
They fled. And this brings us to another crucial piece of evidence for the shark alpha mystery. In 2019, a study from Monterey Bay Aquarium documented what happens when orcas show up in great white territory.
What happens?
The sharks evacuate immediately. The researchers tagged 165 great whites at Southeast Farallon Island off San Francisco between 2006 and 2013. Whenever orcas appeared, even briefly, every single tagged shark fled the area within minutes.
Minutes?
Sometimes the orcas were only present for less than an hour. Didn't matter. The sharks left and didn't come back until the following season, sometimes not for a full year.
That's not a measured response. That's panic.
It's a survival instinct. Dr. Salvador Jorgensen, the lead researcher, put it perfectly. When confronted by orcas, white sharks will immediately vacate their preferred hunting ground and will not return for up to a year, even though the orcas are only passing through.
These are 18-foot sharks, some of them, that have been hunting seals in that area for decades, and they abandon everything the moment they detect orcas.
The study found that in years when orcas showed up, there were 4 to 7 times fewer seal predation events. After the orcas appeared, researchers didn't document a single shark kill on elephant seals for the rest of the season.
The elephant seals must love orca season.
They're the unexpected winners in this predator drama. The seal's 2 main predators show up, one terrorizes the other into leaving, and then the terrorizer doesn't even eat seals. The Farallon orcas mostly eat fish. It's like hiring a bouncer who scares away all the bullies and then doesn't charge admission.
Okay, so we have overwhelming evidence that orcas are apex predators over great whites, that sharks flee in terror from them, and that specialized orca hunters like Port Starboard can kill sharks with surgical precision. This really strengthens the case that an orca ate shark alpha.
It does, but we should still examine the alternative theory because the cannibal shark hypothesis isn't without merit.
All right, let's steel man the cannibal shark theory. What's the evidence that a larger great white ate shark alpha?
First, let's establish that cannibalism in sharks is very real. Cameron Brunn, a researcher at Woods Hole Oceanographic Institution, has stated definitively that cannibalism in sharks is quite common in both juveniles and adults.
Define common.
Great whites have highly variable, opportunistic diets. They'll eat whatever presents an opportunity: fish, seals, sea lions, dolphins, other sharks. Studies off South Africa found that in some locations, other sharks made up a larger portion of great white diets than seals did.
Including other great whites.
Including other great whites. There's documented evidence of great whites actively hunting smaller sharks, and researchers like Ardeen Grubbs at Florida State University have reported having multiple 10 to 12-foot tagged sharks eaten by other sharks.
So a 9-foot shark being eaten by a larger shark isn't unusual.
Not at all. And here's an important context. When shark alpha was tagged, she was on the smaller end of the great white size spectrum. Data compiled by shark researchers shows that about 75% of measured great whites are larger than 3 meters, that's roughly 10 feet. Shark alpha, at 9 feet, was in the bottom quartile.
So, statistically, most great whites she might encounter would be bigger than her.
Significantly bigger. Adult females can reach 20 feet and weigh over 5,000 pounds. Even if only a small percentage of those larger sharks are willing to eat smaller sharks, the numbers work out.
What about the temperature data, the 78 degrees?
This is where the cannibal theory gets scientifically interesting. Great whites are what we call regionally endothermic. They can maintain certain body parts at temperatures significantly above the surrounding water.
The reti mirabile you mentioned?
Right. This wonderful net of blood vessels acts as a heat exchanger, allowing sharks to keep their muscles, eyes, and brain warmer than the cold ocean around them. A large great white in relatively warm surface waters could potentially maintain a stomach temperature around 78 degrees, especially immediately after consuming a large cold meal.
The cold prey would cool down the stomach temporarily.
Exactly. So theoretically, a 16-foot or larger great white could have consumed shark alpha, and the tag would have recorded approximately that temperature.
But there's a problem with this theory, isn't there?
Several problems, actually. First, the post-ingestion behavior. The tag showed movement patterns between the surface and about 300 feet for 8 days. That's very consistent with an air-breathing animal, coming up regularly to breathe. Sharks don't need to surface to breathe.
So a shark wouldn't show that surface diving pattern?
Not typically. Sharks extract oxygen from water through their gills. A great white that just ate a huge meal might rest at various depths, but it wouldn't show the regular surfacing pattern that the tag recorded.
What's the counterargument?
The proponents of the shark theory argue that the predator might have been hunting at the surface, following whale carcasses or seal colonies, which would explain the shallow depth pattern, but it's a weaker fit than the air breather explanation.
What else weakens the shark theory?
The location. The area where shark alpha disappeared, Bremer Bay and the surrounding waters, is known for a fascinating phenomenon. There's a massive hydrocarbon leak from a pocket under the seabed that creates something called methane hydrate, which triggers a whole food chain event.
Explain that.
The methane hydrate causes crustaceans to release billions of nutrient-rich eggs, which attracts small fish, which attracts bigger fish, which attracts, well, everything. It's like an underwater buffet. And one of the apex predators that frequents this area...
Orcas.
Orcas. Bremer Bay has become famous for orca sightings. It's actually now a major ecotourism destination, specifically because of orca aggregations. Dave Riggs, the filmmaker who documented shark alpha tagging, has spent years studying this area and calls it the kill zone.
So orcas are known to be present in exactly the area where shark alpha disappeared.
Very much so. And while we can't prove definitively that an orca ate shark alpha, the ecological context strongly supports that hypothesis.
What does Dave Riggs think happened?
He's publicly stated that the most widely accepted theory is a cannibal great white, but he's also said he's not 100% convinced. He's acknowledged that looking at the thermal profile, 26 degrees Celsius, which is about 78 Fahrenheit, it's pretty high, but not enough to be a mammal.
Wait, he said it's not high enough for a mammal?
His reasoning was that a mammal's core body temperature is typically higher, around 37 degrees Celsius, or 98 Fahrenheit for humans, and similar for orcas. But as we discussed, stomach temperature would be lower than core temperature, especially after ingesting cold prey.
So the temperature data is actually more consistent with a cooled down mammal stomach than a warm shark stomach.
That's the interpretation many researchers favor. The 8-day retention time is also relevant. Orcas have relatively slow digestive systems compared to sharks, which fits the timeline of the tag being expelled after 8 days.
All right, let me play devil's advocate one more time. Is there any other candidate besides orca or cannibal shark?
The internet has had some creative suggestions. Megalodon, the extinct giant shark living secretly in the deep ocean, giant squid, rogue submarines, Godzilla.
Godzilla.
Dave Riggs actually joked in an interview, "I don't think Godzilla is a possibility, though," which, good to have official confirmation on that.
Thank you, science.
But seriously, only realistic candidates are orca or larger shark. Nothing else in that ocean combines the size, predatory capability, and the appropriate thermal signature to explain the data.
And between those two, where do you personally land?
If I had to bet, orca. The behavioral data, the air-breathing surfacing pattern, the thermal profile, the location, and everything we've learned since 2003 about orca predation on great whites all point to a killer whale.
But we'll never know for certain.
Welcome to marine biology. The ocean keeps its secrets.
Let's zoom out from the shark alpha mystery and talk about what we've learned about the relationship between orcas and great whites. Because this isn't just one isolated incident. There's a fundamental shift in how we understand ocean apex predators.
Absolutely. Before October 1997, the scientific consensus was that great white sharks had no natural predators. They were the undisputed kings of the ocean.
What happened in October 1997?
The Farallon Islands incident. A whale-watching boat was near southeast Farallon Island, about 26 miles off San Francisco, when they got a radio call about 2 orcas in the area. When they arrived, a 20-foot female orca and her calf were swimming around, and then a dark shape appeared, a great white shark.
How big?
About 10 feet. And what happened next was captured on video for the first time in history. The female orca attacked, seized the shark, and held it upside down for approximately 15 minutes.
15 minutes? She was inducing tonic immobility.
Exactly. The shark suffocated. Great whites need to keep moving to pass water over their gills, and the orca then fed. What made it extraordinary was that the female apparently killed the shark to teach her calf how to hunt. Witnesses said the calf especially liked the liver.
A mother teaching her baby to hunt great white sharks?
Cultural transmission in action. And the aftermath was almost as significant as the attack itself. Remember what I said about sharks fleeing when orcas appear?
They evacuate immediately.
After that single attack in 1997, the entire great white population at the Farallon Islands, about 100 sharks, disappeared for the rest of the season. Researchers who had been documenting dozens of seal predation events suddenly saw nothing. The sharks were gone.
One attack and 100 sharks fled?
And some of them didn't return for over a year. A tracked shark dove to 500 meters, 1,500 feet, immediately after the attack and essentially went into hiding. Peter Pyle, the shark researcher on site, described it as a traumatic event for these sharks.
That's genuine fear. These apex predators are capable of experiencing fear.
Profound fear. And it makes evolutionary sense. A great white shark can live for 70 years or more. From a survival standpoint, abandoning a feeding ground for a season is a small price to pay for avoiding a predator that could kill you.
How do the sharks know to flee? Are they communicating somehow?
That's still being studied, but sharks have incredibly sophisticated sensory systems. They can detect electrical fields through the ampullae di Lorenzini, specialized pores on their snouts. They have lateral lines that detect vibrations in the water from significant distances. They may be able to sense the electromagnetic signature or sounds of orcas from miles away.
So they feel the orcas coming before they see them.
Possibly. Or they may be responding to chemical signals, fear pheromones from other sharks, or the scent of shark blood and liver in the water. When Port and Starboard are hunting in an area, the water takes on a distinctive oily sheen from the liver fat.
Researchers have described smelling shark liver oil on the surface.
It's one of the ways they know a kill has occurred. The scent is apparently quite distinctive and pungent. If sharks can smell it too, and their sense of smell is extraordinary, it would be like a warning signal, broadcasting across the area.
Murder happened here, get out.
Essentially, yes. And this fear response has cascading effects throughout the ecosystem.
How so?
When great whites abandon an area, their prey species flourish. Seal populations increase, but those seals then impact their prey, fish populations, penguins. The whole food web shifts.
It's a trophic cascade.
Exactly. In South Africa, researchers have documented that the absence of great whites has allowed Cape fur seal populations to expand, which in turn threatens critically endangered African penguins because seals compete for the same small fish the penguins eat.
So 2 orcas hunting sharks could indirectly contribute to penguin decline.
Ecology is complicated. Everything is connected. And when you remove or relocate an apex predator, the ripples spread in unexpected directions.
What about the bronze whaler sharks? I've read that they've moved into areas vacated by great whites.
Right. Bronze whalers are smaller, less dominant sharks that normally give great whites a wide berth. With the great whites gone, bronze whalers have become more common in places like False Bay. But here's the irony. Port and Starboard have started hunting them too.
Of course they have.
Orcas are opportunistic. If great whites are scarce, they'll target the next best thing. Bronze whalers, 7-gill sharks, even ocean sunfish. Port and Starboard aren't picky.
Are other orca populations learning this behavior?
That's the concern. Orcapods share cultural knowledge, and behaviors can spread. There's already a specialized shark hunting pod in the Gulf of Mexico called Moctezuma's pod that has developed similar techniques, targeting great whites, flipping them, extracting livers.
So this could become more widespread.
Potentially. If more orcas adopt shark hunting as a primary strategy, it could have significant implications for shark populations globally. And sharks are already under pressure from overfishing, finning, and habitat loss.
How many great whites are there globally?
Estimates vary wildly, but most populations are considered vulnerable. There might be a few thousand in the Northeast Pacific, similar numbers off South Africa and Australia. We're not talking about millions of individuals.
So losing dozens to orca predation actually matters.
Especially if they're adults. Great whites mature slowly. Females don't reproduce until they're about 15 to 20 years old. Each adult represents a significant investment in survival. Losing breeding females to predation can impact population growth for decades.
This is genuinely concerning from a conservation perspective.
It is. And it's made more complicated because orcas are also protected. You can't exactly tell Port and Starboard to stop hunting sharks. This is natural predator behavior, just one we didn't know was happening at the scale until recently.
Nature doesn't care about our conservation categories.
Not even a little bit.
Let's bring this back to the deeper question. What does all of this tell us about who's really at the top of the ocean food chain?
It tells us that our assumptions were wrong. For decades, we thought of great white sharks as the ultimate marine predator, the apex of the apex. And culturally, that image is deeply embedded. Jaws, Shark Week, every beach movie ever made.
Great whites are the movie monsters.
They're the perfect villains because they look like villains. Those dead black eyes, the rows of serrated teeth, the silent approach from below. But in reality, great whites are complicated. They're intelligent, curious, often cautious, and they're very much not at the top of the food chain.
Orcas hold that position.
In most marine ecosystems, yes. Orcas are larger. Adult males can reach 26 feet and weigh 12,000 pounds, dwarfing even the biggest great whites. They're faster, more maneuverable, and they hunt in coordinated groups. Perhaps most importantly, they're extraordinarily intelligent.
How intelligent?
orca brains are about 4 times the size of human brains, with highly developed limbic systems associated with emotion and social processing. They have distinct cultures, dialects, hunting techniques that vary by population. They teach their young, they mourn their dead.
And they figured out how to hunt one of the ocean's most fearsome predators?
Not just hunt, strategically target for maximum caloric return. The liver extraction technique isn't random violence, it's optimized predation. Why waste energy consuming an entire tough, cartilaginous shark body when you can precisely extract the one organ that provides the most nutrition?
It's almost disturbingly efficient.
Hannibal Lecter of the sea is how one researcher described watching Port Starboard work. The precision is unsettling.
Let's talk about that precision. How do they know where the liver is? How did they develop this technique?
We don't know for certain. Orcas may have innate knowledge of shark anatomy. Prey species often have hardwired vulnerabilities that predators exploit. Or they may have learned through trial and error over generations. The fact that similar techniques have developed independently in different orca populations suggests there might be some instinctual component.
Like they're biologically programmed to recognize sharks as prey?
Possibly. Orcas in different parts of the world have developed radically different hunting specializations. Some eat only fish, some hunt seals by washing them off ice floes, some target whale calves in coordinated attacks. This dietary specialization seems to be culturally transmitted within pods, but may build on innate predatory instincts.
So a calf born into Port Starboard's pod would likely learn shark hunting.
If there is a pod, interestingly, Port Starboard are usually seen as a pair without a larger social group. This is unusual for orcas, who typically live in matrilineal pods. Some researchers speculate they may be older males who've separated from their natal pod, which could explain their specialized hunting behavior.
Lone wolves of the sea.
Lone orcas of the sea. Though lone is relative, they have each other, and their coordination suggests a deep partnership.
Has anyone figured out how they communicate during hunts?
Orcas use a sophisticated repertoire of clicks, whistles, and pulsed calls. Different pods have distinct dialects. During hunts, they likely coordinate through vocalizations and echolocation, maintaining awareness of each other's position and the prey's movements.
So they're literally talking to each other while hunting?
In a sense, though we don't fully understand what they're saying, orca communication is one of the great unsolved mysteries of marine biology.
What's the current status of Port Starboard? Are they still active?
As of early 2024, they're still being regularly spotted off the South African coast. They've continued hunting sharks in various locations, expanding their range. Every few months, there are new reports of shark carcasses washing up with the telltale liver extraction wounds.
And the great whites haven't adapted?
Adapted how? Their main response is avoidance, leaving areas where orcas are present. But if Port Starboard keep expanding their hunting grounds, the sharks run out of places to flee.
It's like a horror movie where the monster keeps following you.
Except in this case, the monster is actually displaying remarkable intelligence and specialized hunting behavior. From the orca's perspective, they're just efficiently obtaining nutrition.
Does this change how we should think about great white sharks? Does it make them less fearsome?
I think it makes them more interesting. Here's an animal that's been refined by 400 million years of evolution into an incredibly effective predator. And yet, against certain opponents, it's vulnerable. It knows fear. It makes strategic retreats.
It's not a mindless killing machine.
Exactly. Great whites are making decisions constantly. Where to hunt, when to approach, when to flee. They assess risk. They learn from experience. Older sharks know to avoid areas where they've encountered orcas before.
That's actually comforting from a human perspective. If sharks can assess risk and make decisions, maybe they're less likely to randomly attack swimmers.
The data supports that. Great white attacks on humans are incredibly rare. Fewer than 60 unprovoked bites globally per year across all shark species. And most of those aren't fatal. Many researchers believe that when great whites do bite humans, it's often a case of mistaken identity. A surfboard silhouette looks a lot like a seal from below.
and then they realize we're not worth eating.
Humans are bony, not very fatty, and apparently don't taste good to sharks. Most attack victims are released after a single bite. The shark takes a sample, realizes its mistake, and leaves.
Cold comfort if you're the one being sampled.
True, but statistically, you're far more likely to be killed by a cow, a dog, or a falling coconut than by a shark.
Falling coconuts kill people?
About 150 people per year compared to fewer than 10 from shark attacks. Perspective is important.
All right, as we wrap up, let's bring this full circle back to Shark Alpha. What's the definitive answer to what ate that 9-foot great white?
The honest answer is we don't know with certainty. The evidence points most strongly toward an orca. The thermal signature, the behavioral data, the location, and everything we've learned since 2003 about orca predation on great whites. But without direct observation, we can't rule out a very large cannibal great white.
So the mystery remains.
The specific mystery, yes. But the broader mystery, what hunts the hunter, has been definitively answered. We now know that great white sharks are not the apex predators we believed them to be. They have a natural enemy that they fear, flee from, and can't defend against.
And that enemy is the orca.
The killer whale, which ironically isn't a whale at all. It's the largest member of the dolphin family. We even named it wrong.
Marine biology is full of misleading names.
Don't get me started. But here's what I want listeners to take away from this. The ocean is far more complex than we imagined. These aren't simple predator-prey relationships. They're dynamic, strategic interactions between intelligent animals making sophisticated decisions.
The great white that fled for a year after witnessing an orca attack wasn't acting on blind instinct.
It was making a calculated survival decision. And that's what makes studying these animals so fascinating. There's real cognition happening beneath those prehistoric exteriors.
What's next for this research? Where do we go from here?
More tagging, more observation, better technology. Satellite tags are improving constantly. We're getting longer tracking data, more detailed behavioral information. Every year we learn something new about how these predators interact.
And about the ocean's hidden hierarchies.
Exactly. For every answer we find, 10 new questions emerge. We've only explored about 5% of the ocean. Who knows what other relationships are playing out in the depths that we haven't witnessed yet?
That's simultaneously exciting and terrifying.
Welcome to marine biology.
All right, final question, and I ask this every episode. Should I be worried, like personally, about orcas, sharks, any of these apex predators?
No. Despite their fearsome reputations, there are 0 confirmed fatal orca attacks on humans in the wild ever. And shark attacks, while they get massive media coverage, are statistically negligible.
But something could eat me if I went swimming off Bremer Bay?
Something could eat you crossing the street in any city. Risk is everywhere. The ocean just makes people more anxious because it's unfamiliar and because whatever might eat you is hidden beneath an opaque surface.
The fear of the unseen.
Exactly. But if there's one thing the Shark Alpha story teaches us, it's that even apex predators live with fear. Even the hunter can become the hunted. There's a strange democracy to predation. Everyone is vulnerable to something.
That's either deeply philosophical or deeply unsettling.
Why not both?
Fair enough. Elena, this has been incredible. Thank you for illuminating one of the ocean's most fascinating mysteries.
Thanks for having me, Marcus, and thanks to everyone who listened for diving deep with us. And if you're ever in South Africa or Australia, consider supporting responsible shark ecotourism. These animals need advocates.
Until next time, keep asking questions. I'm Marcus Chen.
And I'm Dr. Elena Vasquez. Remember, in the ocean, there's always a bigger fish. Or in this case, a bigger dolphin.
On that note, goodbye, everyone.